Tonight, we drift slowly above a stretch of cold grey water between the eastern coast of Britain and the low shores of the Netherlands, Denmark, and Germany. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap, and a new story is waiting for you every evening. From high above, this place looks like nothing more than ordinary sea, a wide, restless plain of waves. Fishing boats trace their slow paths across it. Cargo ships move through the long shipping lanes that stitch one harbor to the next. Wind farms turn in the salt air, their tall white towers leaning into the steady breeze. Yet what lies below the keel of every boat out there is not simple ocean floor. It is the buried surface of a country that no living person has ever walked. A real place, with real rivers and real hills, real forests and real meadows. A place where deer once browsed and reeds once whispered in summer wind. A place where small fires once burned at the edges of quiet lakes. We call it Doggerland now, after a shallow rise in the seabed called Dogger Bank. The name is modern. The land itself is far, far older. Picture, for a moment, the North Sea drained away, the water gone. What you would see is not a flat, empty basin. You would see soft rolling country, low chalk ridges, broad river valleys carved by water that has long since lost its way. You would see the wide mouth of a great river system that gathered the flows of the Thames, the Rhine, the Meuse, and the Elbe into one slow, braided giant before it emptied somewhere far to the north. You would see lakes and marshes. You would see places where the ground rose just enough to feel like dry, comfortable land in a cool northern climate. That country is still there. It did not vanish. It only sank, or rather, the sea climbed up over it. The hills are still hills. The valleys are still valleys. They are simply buried under tens of meters of cold, salty water and a soft blanket of silt. The shapes of the old world are preserved in the dark, like a sleeping face beneath a sheet. The mystery that pulls at us tonight is this: what kind of world was it, really? Who walked there? What did the seasons feel like on its long, open plains? And why, in the end, did it disappear so thoroughly? The big shape of the story is something most researchers agree on. After the last great ice age, the glaciers melted, the seas rose, the low country between Britain and Europe slipped beneath the waves over thousands of years. That much is steady ground. The finer questions, though, stay open. One view holds that the drowning was a slow, patient thing, a matter of generations, watching the marshes creep a little further inland each summer. Another view, drawn from the seafloor itself, suggests there were sudden shocks along the way, moments when the water came faster than anyone could have imagined. Whether the people living on that land had time to leave, or whether some of them were caught by the rising tide, is still a question scholars turn over carefully. The evidence is fragmentary. The cold water keeps most of it hidden. For tonight, all you need to do is picture the scale. A landmass roughly the size of a small country, lost beneath the sea within a span of time that feels short in the long history of the earth. A place that linked an island to a continent and then quietly let them part. A place where mammoth bones and human tools still rest in the silt, sometimes pulled up by accident in the nets of trawlers working far from shore. Think of the listener, of those waves above your bed tonight, the same waves that once washed across forest floors, the same horizon that once held the smoke of small fires, the same wind that once stirred grasses where now it stirs only the surface of the sea. We will spend the next many hours drifting through what is known and what is not known about this drowned country. We will visit its rivers, its animals, its hunters, its forests of black peat. We will sit with the theories. We will sit with the silences between them. We will not solve the mystery tonight. No one has solved it yet. We will only let it carry us gently into sleep, the way the tide carries an old piece of bone slowly across the floor of a sea that used to be a meadow. Let us begin with the simplest picture, the one we can hold in the mind before sleep takes over. Picture the North Sea on a quiet evening. The water stretches grey and flat between the eastern coast of Britain and the low shores of the Netherlands, Germany, and Denmark. Ships move slowly across it. Wind ruffles the surface. Somewhere out there, a fishing trawler drags its nets through the dark. Now imagine all that water gone. In its place, a wide green land, flat in some parts, gently rolling in others, rivers winding through it, marshes and reed beds, stands of oak and birch and hazel, small hills rising here and there like soft shoulders above the plain. This is the basic picture of Doggerland, the lost country that once filled the basin of the North Sea. It is not a legend. It is not a half-remembered story. It is a real place, well known to geologists, and it lay beneath the open sky for thousands of years. The mystery is not whether it existed. The mystery is what life on it looked like, and why its ending came on so completely. Some numbers may help, though numbers can feel slippery in the dark. The area we now call the North Sea covers about 220,000 square miles of water. That is a little larger than the state of Texas, or roughly the size of Britain, Ireland, the Netherlands and Belgium, laid down side by side. During the coldest part of the last ice age, much of that area was not sea at all. It was open ground. A person could have walked from what we now call Norfolk, in eastern England, all the way to the German coast without once getting their feet wet. The land was not high. Most of it lay only a few dozen feet above sea level. In places, it rose into modest ridges, and one of those ridges, far out from the modern English shore, is still there beneath the waves. Fishermen call it the Dogger Bank. It is a long sandy shoal where the water suddenly becomes shallow, sometimes only 50 or 60 feet deep, in a sea that elsewhere goes much deeper. The Dogger Bank is what gave Doggerland its name. It is, in a sense, the last visible shoulder of a drowned country. The age of this lost land is harder to fix with a single date, because Doggerland was not one thing. It changed shape across many thousands of years. At the height of the last glaciation, about 20,000 years ago, sea levels were roughly 400 feet lower than they are today. That is about the height of a 40-story building. With so much of the world's water locked up in vast ice sheets, the shallow basins of the world simply dried out. The North Sea basin became part of a single great plain that joined Britain to the rest of Europe. Then the ice began to melt, slowly at first, then less slowly. The seas rose, century after century, and the plain began to shrink. By around 8,000 years ago, only scattered islands remained. Soon after that, even those were gone. The water closed over the last of Doggerland, and the land that had hosted forests, rivers, herds, and people became seabed. So in the simplest terms, Doggerland was a low, broad, gentle landscape, roughly the size of a medium European country, that existed for many thousands of years and ended underwater. It is older than the pyramids. It is older than writing. It is older than farming in most of the world. The hunters who walked it were modern humans, the same species as you and me, with the same brains and the same curiosity. They simply lived in a place that no longer exists. The composition of this lost ground beneath today's seabed is mostly soft sediment, layers of clay, peat, sand and silt, pressed down by the weight of the water above. With those layers rest the bones of animals that once grazed there, the seeds of plants that once grew there, and sometimes the tools of the people who once hunted there, the whole archive of a vanished world, stacked in quiet bands beneath the waves. This is the ground we will be walking, in a sense, for the next few hours, a flat green country no living person has ever seen with their own eyes, a place we know existed, and yet a place whose daily life, whose voices, whose villages remain almost entirely beyond our reach. The basics are settled, the deeper questions are not, and those deeper questions are what we will sit with, gently, as the night moves on. The name itself comes from a fish, or rather from the boats that once chased the fish out in the southern North Sea. Far from any coastline, the seafloor rises into a long, shallow bank. Sailors of past centuries knew this bank well. It was a good place to catch cod, and the small wooden vessels that worked these waters were called doggers. The shallow place they returned to, year after year, came to be known as the Dogger Bank. When researchers began to suspect that this bank was the last high ground of a much larger drowned country, they reached for the old fisherman's name and stretched it. They called the lost land Doggerland. The word is fairly new, only coined in the late 20th century by a British archaeologist who wanted a single, simple label for something that had previously gone unnamed. Before that, the drowned plain had no name at all. It had simply been the bottom of the sea. The naming matters more than it might seem. Once a place has a name, people can look for it. Maps can be drawn, questions can be asked. Without the word Doggerland, the lost country stayed scattered across fishermen's stories and stray bones in museum drawers. With the word, it became a place again, a place worth searching for. The maps we now draw of Doggerland are strange and humble things. They are not made from photographs. No traveller ever walked its hills with a sketchbook. Every line on every Doggerland map is a guess built from echoes. Survey ships drift slowly above the cold grey water, sending sound pulses down to the seabed and listening for the returns. The echoes carry hints of buried river channels, soft folds where lakes once sat, the faint scar of an old shoreline. From these whispers, cartographers build their charts. Hold one of these maps in your mind for a moment. Picture a long, low country stretching from the east coast of what is now Britain across to the low hills of the Netherlands and the cold flats of Denmark. Picture wide rivers flowing through it, and shallow lakes and gentle ridges no higher than soft, rolling farmland. Picture marsh grass in the lowlands and dark pine forest on the slightly higher ground. The map shows none of this directly. The map shows only the shapes of valleys and ridges hidden under the modern seabed. The grass and trees are added by imagination, drawn from pollen grains preserved in old mud. Different research teams produce slightly different maps. One survey might trace a great river running roughly north, swollen by meltwater from distant glaciers. Another team, working a few years later with better instruments, might redraw that river along a different course. The shape of the lost land keeps shifting in our hands. We are still learning where its hills rose and where its lakes pooled. We do not yet have a single agreed upon map of Doggerland. We have many overlapping sketches, each one a little clearer than the last. The origin story of the place reaches back much further than the name. To understand how Doggerland came to exist, the mind must travel to the long, cold ages when ice sheets covered much of northern Europe. Vast walls of ice locked away enormous amounts of the world's water. With so much water held in the ice, the seas stood far lower than they do today. The shallow basin we now call the North Sea was simply dry ground, exposed, weathered, slowly shaped by wind and water, and the slow movement of the land itself. As the ice began to retreat, meltwater carved channels across this exposed floor. Rivers from what is now Germany, the Netherlands, and eastern Britain wandered together across the open plain. Sediment settled, soil thickened. Plants crept north as the climate softened. Animals followed the plants, and people followed the animals. By the time the world warmed into something close to its present mildness, Doggerland was a living country, green, watered, populated, and entirely unaware of what was coming. So when we say Doggerland was born, we mean it was uncovered, then settled, then made into a place by the patient work of melting ice and patient roots and patient feet. It took thousands of years to become itself. The maps we draw now show only the bones of that long becoming, where the soft tissue lay, the grasses, the hearths, the trails worn by daily walking. We can only guess. That gap between what the sonar sees and what once lived there is the gap our wandering fills. It is also the quiet space where this mystery still waits. Beneath the cold grey water of the North Sea, there are rivers that no longer reach the sea. They still exist, in a way. Their channels are still cut into the seafloor. Their old curves still wind through the mud and clay, but the water no longer flows along them. The sea has swallowed both the river and the land it crossed. To understand what Doggerland was made of, we have to think about water first. Fresh water, mostly. Slow water, the kind that gathers in lowland Europe and drifts north toward the colder shores. The Thames once flowed much farther than it does today. It crossed what is now the southern North Sea and joined a great river system in the middle of that vanished plain. The Rhine flowed the other way, from the south, gathering meltwater from distant glaciers. The Meuse joined it. Other, smaller rivers from what is now the Netherlands and northern Germany joined too. They all met in a wide, slow-moving river that ran north through the heart of Doggerland. That great river had no name we remember. Researchers sometimes call it the Channel River, or simply the Lost River of the North Sea Plain. It carried clay and silt and small stones scraped from the soft hills of Europe and dropped along the way. Those sediments are still down there. They form the soft layers that ships pass over without ever knowing. The building blocks of Doggerland were the building blocks of any rich lowland. Sand, clay, peat, chalk underneath, in some places white and soft and full of tiny ancient shells. Each of these materials has its own long story. The chalk under the southern North Sea formed from the skeletons of countless tiny sea creatures that lived in warm seas long before the ice ages. Each microscopic shell was made of calcium carbonate, a simple compound of calcium, carbon, and oxygen. The calcium itself was washed off ancient continents by rain. The carbon came from the air, pulled down into the water by living things, and the oxygen, that endless, ordinary oxygen, was breathed out by the green plankton drifting at the surface. Above the chalk lies sand. Sand is mostly quartz, a tough mineral made of silicon and oxygen. Silicon is one of the most common elements in the Earth's crust. It was forged inside stars that lived and died long before our sun was born. When those stars ended their lives, they scattered silicon into space. That silicon eventually became part of the rocky planet we walk on. So in a quiet, almost unbelievable way, the sand beneath the North Sea was once stardust. The peat is younger and stranger. Peat is partly rotted plant matter, pressed down over thousands of years. The peat beds of Doggerland hold the remains of reeds, grasses, mosses, and the leaves of long fallen trees. When fishermen pull up dark, fibrous lumps in their nets, they are sometimes holding pieces of forest floor that have not seen the sun in 8,000 years. Then there is the water itself. The North Sea is salt water now, but the water cycle that fills it is older than any sea on Earth. Most of the water on this planet has been here since the planet was young. Some researchers think much of it came from icy bodies that struck the early Earth, comets and water-rich asteroids, though the exact proportions are still debated. Other water may have been locked inside the rocks of the young Earth and slowly released by volcanoes. The question of where Earth's water came from remains genuinely open. Whatever its origin, that water flowed through Doggerland in many forms, as rain soaking into the peat, as rivers winding past hunting camps, as mist over the marshes in the early morning, as ice in the long winters, and eventually as a rising tide that would not stop. The iron in the soil of Doggerland came from even further back. Iron is forged in the cores of large stars in the last stages of their lives. The reddish tint in old riverbed clays, the rust on a long-buried tool, all of that iron was made in a star that died before our solar system existed. The hunters who once walked across that plain carried bone and antler and flint, but the soil under their feet was scattered with starlight, made solid. It is a strange thought to hold as you drift towards sleep. A drowned country, made of stardust and ancient shells, watered by rivers that no longer reach the sea. The materials are still there. The shape of the rivers is still there. Only the people, the animals, and the open sky are gone. To picture Doggerland properly, it helps to step back and see the wider stage on which it sat. For most of the last ice age, much of northern Europe was not the green divided place we know today. It was one vast, low plain, stretching from what is now eastern England all the way across to Denmark, the Netherlands, and the cold flatlands of northern Germany. There were no narrow seas between these places. There was only land, quiet, open, wind-brushed land. The forces that shaped this plain were slow and patient. The greatest of them was ice. Far to the north, enormous sheets of ice sat heavy on the land, in some places more than a mile thick. Their weight was so great that it actually pressed the crust of the earth downward, like a thumb pushing into soft clay. The rock beneath the ice sagged. The rock around the edges, in response, bulged gently upward. This slow flexing of the crust is something geologists call isostasy, the way the solid ground floats on the hotter, softer layers far below. Doggerland sat near the edge of these great ice sheets. It did not lie under the ice itself, at least not at the end. It lay just beyond, on the broad apron of land that had been pushed up slightly by the weight pressing down to the north. So the very shape of the plain was, in part, a gift of the ice. Without those frozen mountains in the distance, the land beneath the future North Sea might have looked very different. Another quiet force was water, locked away in solid form. So much of the planet's water sat frozen in the ice sheets that the oceans themselves were lower. At the deepest cold of the Ice Age, sea levels may have stood around 120 meters below where they sit today. That is a staggering drop. Whole continental shelves, which now lie under shallow seas, stood high and dry in the open air. The North Sea basin was one of them. So was the English Channel. So were vast stretches of coastline all over the world. Gravity played its part too, though in a gentler way. Rivers that flowed across the Great Plain were pulled as all rivers are, towards the lowest ground they could find. With the sea so far away, those rivers ran for hundreds of extra miles before reaching salt water. The Thames, the Rhine, the Meuse, and others joined together in slow braided channels across the plain. Their currents carved shallow valleys. Their floods spread silt and clay. Over thousands of years, this constant soft sculpting smoothed the land into gentle rolls and wide marshy lowlands. Wind, too, worked on the surface. Cold winds spilling off the distant ice carried fine dust, called loess, and laid it down in pale blankets across parts of the plain. In other places, the wind stripped away loose material, exposing harder ground beneath. The result was a patchwork of soils, some rich and fertile, some thin and stony, all stitched together by the lazy meanders of the rivers. Beneath all of this lay the deep memory of older forces. The bedrock under Doggerland records ancient seas, ancient deserts, ancient swamps. Some of that buried rock holds the chalk that now forms the white cliffs on either side of the modern channel. Some of it holds the gas and oil that today's rigs draw up from far below the waves. These layers were laid down over hundreds of millions of years, long before any human walked here. They formed the quiet floor on which the Great Plain came to rest. What makes this part of the story so interesting is how delicate the balance was. A small change in temperature, sustained over centuries, could lock more water into ice and drop the sea further, exposing even more land. A small warming the other way could melt the edges of the sheets and let the sea creep back. Researchers still debate exactly how steady or how jumpy that balance was. Some think the changes were mostly gradual. Others suspect there were sharp pulses when meltwater suddenly poured off the ice and raised the sea by surprising amounts in a short time. The evidence is still being read. For now, picture the forces at work as a kind of breathing. The ice grows and the plain widens. The ice shrinks and the sea comes home. Doggerland existed in one long exhale of that breath. And the question of how steadily or how unevenly that breath turned back into an inhale is one we will keep returning to as the night goes on. Picture, for a moment, the scale of what lies beneath the cold grey water. The North Sea today stretches across roughly 220,000 square miles. At its widest, before the melt, the dry land beneath it may have covered an area larger than the modern United Kingdom. That is a country-sized world, gone. Not a small patch of beach, not a strip of coast, a whole landscape, with rivers and ridges and quiet wooded valleys, now resting under hundreds of feet of salt water. Try to hold that in your mind as you settle into the pillow. If you could drain the southern North Sea tonight, you would not see a few scattered hills. You would see a plain so wide that a person standing in the middle could walk for many days in any direction without reaching the shore. The Thames would stretch on past its modern mouth and keep going. The Rhine would join it. Together they would carry water across hundreds of miles of low green country before finally reaching the sea somewhere far to the north. The time scale is just as wide. The world we are wondering about existed across thousands of years. Not a single moment, but a slow chapter of Earth's story. Around 20,000 years ago, at the coldest point of the last ice age, sea levels were perhaps 400 feet lower than they are today. That is the height of a 40-story building. Imagine the ocean dropping that far. Imagine the new land that would appear. The shorelines of the world were not where they are now. They were far out, in places we now think of as deep water. Doggerland, in those cold centuries, was part of a larger frozen plain. Then the ice began to melt. Over the next 10,000 years or so, the sea rose. It did not rise all at once, and it did not rise at a steady pace. Some centuries saw slow change, others saw faster pulses. By around 8,000 years ago, most of the land was gone. By around 7,000 years ago, the last low islands had likely slipped under. Think about that span. 10,000 years. If you place one human lifetime end to end, that is more than 100 lifetimes of grandparents, passing the story down to grandchildren, generation after generation, watching the water creep a little closer to the old camps, watching familiar hills become islands, watching islands become shallow banks, watching shallow banks become memory. The depth of the water above the lost land varies in some places the modern North Sea is only 60 or 70 feet deep. That is roughly the height of a 5-story building. A swimmer at the surface is just a short fall above the old ground. A trawler dragging its nets across the seafloor is dragging across what was once dry earth. In other places, especially toward the north, the water is deeper. But across much of the southern North Sea, the lost world is not buried far below us. It is close. It is almost within reach. The hunters who walked there were people much like us. Their bodies were the same. Their brains were the same. They built fires and shaped tools and told stories around the embers. Mesolithic peoples, as researchers call them, lived across this lowland for thousands of years. How many of them there were, no one can say with confidence. Some estimates run into the tens of thousands across the wider region. Other estimates are far lower. The honest answer is that the population of Doggerland remains an open question, and the seafloor has not yet given up enough evidence to settle it. What we do know is the geography of their footsteps. A person standing on a low ridge in central Doggerland, around 9,000 years ago, could have looked east toward what is now Denmark, west toward what is now eastern England, and seen no sea in either direction, just rolling country, reed beds, slow rivers, smoke from distant cooking fires perhaps. The sea was a rumor on the northern horizon, far away. Today, ships sail directly above those old ridges. Container vessels, fishing boats, ferries crossing between ports. The hum of their engines passes over the buried valleys without a pause. The people on board look out at a flat expanse of water and see nothing of what lies beneath. And yet, only a short distance below the hull, the old ground is still there. The shape of it is still there. The question of who walked it, and how they lived, and how they finally left, is still there too, waiting, patient, in the dark water. For most of the last century, the surface of Doggerland has come back to us in small, strange pieces, lifted from the dark by accident. Picture a fishing boat far out in the North Sea, somewhere between the coast of eastern England and the low shores of the Netherlands. The water is grey-green, the sky is low and soft. The crew haul in their heavy nets, expecting cod, expecting plaice. Instead, mixed in with the silvery flap of fish, something dark and heavy thuds onto the deck. A bone, longer than a man's arm, pitted, sea-worn, the color of old tea. This has happened thousands of times. Trawlers working the shallow banks have pulled up the rib bones of mammoths, the curling tusks of woolly elephants, the heavy skulls of aurochs, those huge wild cattle that once roamed across Europe. They have brought up the antlers of red deer, the jawbones of wolves, the small delicate teeth of horses. They have brought up flint tools, shaped by careful hands, with edges still sharp enough to nick a thumb. And on rare days, they have brought up something even quieter and more startling. A piece of human bone. If you could stand on the deck of one of those boats and look at the gathered finds, you would see a sort of accidental museum. The colors are muted, almost gentle. Bone bleached to ivory, then stained back to brown by centuries in the silt. Flint in soft grays and honeyed yellows. Antler, the color of weathered wood. Everything carries the smell of salt and old mud. Everything is cold to the touch, even on a summer afternoon. The surface of Doggerland, then, is not really lost. It is simply scattered. It lies in museum drawers, in small coastal towns, in the back rooms of universities, in the homes of fishermen who keep odd bones on their windowsills. For a long time, no one quite knew what to make of these objects. In the 19th century, sailors thought the bones might be from elephants brought to Britain by Roman armies. Others believed they were the remains of animals that drowned in the great biblical flood. The truth, slowly pieced together, turned out to be stranger and quieter. These creatures had not been carried here. They had lived here on dry ground long before the sea arrived. The seafloor itself, if you could drift down to it, would look surprisingly gentle. Much of the southern North Sea is shallow, in some places only 20 or 30 meters deep. The bottom is mostly sand and silt, rippled by tides, dotted with patches of darker mud. In places, peat lies beneath the sand, soft, spongy, dark brown, the compressed remains of ancient marshes and forests. Trawlers sometimes drag this peat up too, and when it dries on the deck, you can see tiny twigs and leaves still pressed inside it, perfectly preserved. There are ridges and shallow banks out there with names like Dogger Bank, Brown Bank, Lehman and Ower Banks. These are the high points of the old country, the hills that resisted the rising water the longest. Above them, the sea is paler, sometimes only a few meters deep. Fishermen have always known that these places yield the strangest catches. One theory is that the bones gather there because the currents sweep finer sediment away, leaving heavier objects exposed. Another idea is that these higher grounds were simply richer places to live, with more animals, more camps, more lost or buried things. What remains unresolved is how complete a picture these scattered finds can ever give us. Every bone pulled up in a net has lost its context. We cannot know exactly where it lay, or what was beside it, or what season the animal died in. We have fragments without a map. Some researchers believe that with enough finds, patient cataloguing, and careful dating, a rough portrait of life on Doggerland can still be built. Others worry that too much has already been churned and scattered by centuries of trawling for the picture to ever come clear. For now, the surface of Doggerland reaches us one quiet piece at a time. A tusk in a fisherman's shed, a worked flint in a small glass case, a child's tooth in a paper envelope labeled in pencil with the coordinates where it was found. Each object is a small window into a place that no living person has ever seen with their own eyes, and each one carries the same soft, unanswerable question: what was the rest of it like? The whole wide country these scraps once belonged to, sleeping now beneath the slow grey tide. In the late summer of 1931, a small fishing boat called the Calinda was working the shallow waters between England and the Netherlands. The crew were dragging their nets across a stretch of seabed known as the Lehman and Ower Banks. When they hauled up their catch, they found something tangled inside a lump of dark peat. It was not a fish. It was a long, slender point of antler, carefully shaped and grooved along, one edge made by a human hand thousands of years before. The find became known as the Calinda Point. It was a barbed harpoon, the kind hunters once used to spear fish or perhaps small game, in the shallows. The antler was old, very old. Later tests would suggest it had been made somewhere between 10 and 14,000 years ago, when the seabed beneath the Calinda's hull had still been dry land. The harpoon had not drifted there. It had been dropped, or lost, or left behind on a riverbank by someone who walked across what we now call Doggerland. For a long time, the Calinda point sat in a museum drawer as a curiosity. Few people knew what to make of it. A single tool, pulled from the dark mud of the North Sea, did not yet add up to a lost country, but it raised a quiet question that has never fully gone away. If one harpoon could survive down there, in the cold and the silt, how many others might still be waiting? And what could a single shaped piece of antler really tell us about the people who made it? The honest answer is that it tells us less than we would like. We know the maker understood how to shape antler with care. We know they hunted in or near water. We know they were part of the broader Mesolithic world that stretched across northern Europe at the end of the last ice age. Beyond that, the harpoon keeps its secrets. It does not tell us the maker's name, or their language, or what songs they sang while they worked. It does not tell us whether they lived nearby year-round, or only passed through in a certain season. Since the Calinda point, more objects have surfaced from the seabed. Worked flints, small blades, bone tools darkened by long burial in peat. Each one is a single point of light in a wide black room. Researchers try to gather these scattered points and sketch a picture of daily life. But the picture stays blurred at the edges. One theory holds that Doggerland was a busy, densely settled land, full of camps along its rivers and lagoons. Another suggests it was more thinly peopled, used by small bands who moved through the lowlands, following herds and tides. Both ideas use the same handful of objects. Both could be partly right. The harpoon also raises a deeper puzzle about preservation. The North Sea is not kind to ancient things. Storms churn the seabed. Currents shift the sand. Trawl nets scrape across the bottom, day after day, year after year. Most of what once lay on Doggerland's surface has likely been broken, scattered, or buried beyond reach. The Calinda point may have survived only because it was sealed inside a block of peat. A soft brown shield that kept water and oxygen away from the antler for thousands of years. Some researchers wonder how much more might still be hidden inside similar peat layers, locked in the dark like pages in a closed book. Others are more cautious. They point out that peat itself is fragile, and that much of it has already been eroded away or dredged up by accident. The seabed, in this view, is not a sealed archive, but a slowly emptying one. Whether the harpoons and tools still waiting down there number in the dozens, the thousands, or the millions, no one can yet say. The sampling is too thin. The sea is too wide, so the Calinda point sits in its quiet drawer, a small curved piece of antler with a row of careful barbs. It is one of the very few direct touches we have from a vanished world. It was held, once, by warm fingers on a riverbank that no longer exists. It was set down, or thrown, or lost in a moment we cannot reach. Then the water rose, the peat formed, the centuries piled up, and a fishing net pulled it back into the light. What else lies beside it in the dark mud? We do not know. The question stays open, slow and patient, drifting somewhere beneath the grey waves above the old shore. Sometimes, when the tide pulls far out along certain coasts of England, something strange appears in the wet sand. Dark stumps, twisted roots, the shapes of old trees lying on their sides, half buried in the mud. They look almost like driftwood at first. But these trees did not float here. They grew here long ago, when this stretch of ground was a living forest. These are the remains of what people sometimes call a drowned forest. You can find them in places like Borth in Wales, or along the shores of Norfolk, or near the cliffs of Cornwall. When storms wash away the sand, the stumps come back into view. Some are 5,000 years old. Some are older. They stood once in the open air, with birds in their branches and soft soil around their roots. Now they rest under the same waves that hide the rest of Doggerland. These forests give us a small window into a long, slow cycle. The land here did not flood all at once. It breathed in and out over thousands of years as the climate shifted and the ice came and went. Forests grew. Forests died. New forests rose on the bones of the old, and the sea very slowly kept reaching closer. To understand the rhythm, you have to think in long, patient time. The Earth tilts a little as it spins. Its orbit stretches and shrinks. These slow changes affect how much sunlight reaches the northern lands. Over tens of thousands of years, the ice sheets grow heavy, then thin, then grow heavy again. When the ice is thick, the sea is low because so much water is locked away as frozen white. When the ice melts, the sea rises and the low places of the world go under. Doggerland sat at the mercy of this slow pulse. During the coldest times, the North Sea was not a sea at all. It was open ground. Mosses and grasses spread across it. Then, as the air warmed, the trees came. Birch first, with its pale bark and small bright leaves. Then pine, then hazel, then oak. The forests rose in waves, each kind of tree taking its turn as the climate softened. We know this because of pollen. Tiny grains of pollen settle into peat and mud and stay there for thousands of years. When scientists pull up cores from the seabed, they find these grains layered like pages in a book. Each layer holds a different mix of trees and plants. The pages tell a story of a land changing its clothes over and over again. Cold tundra, open birch woodland, dense oak forest, wet marsh, salt-touched reed beds. Then, finally, no land at all. The puzzle is how steady this rhythm really was. One view holds that the change came in slow, even steps, as the meltwater trickled in year by year. Another view suggests the cycle had sudden jumps inside it. Cold snaps, brief warm spells, moments when the sea climbed faster than people could have noticed in a single lifetime, and other moments when it seemed to pause for centuries. The pollen pages hint at both. Which pattern truly shaped Doggerland is still being worked out. There is also the question of what those drowned forests felt like while they lived. Were they quiet, shaded places, with deer moving between the trunks? Were they patchy, broken up by bogs and shallow lakes and slow brown rivers? Did people walk under those branches with bows and woven baskets? Or were these forests, in their final years, already too wet and too lonely for many to stay? The fallen stumps cannot quite tell us. They only tell us that the trees were here, and then they were not. When you stand on a modern beach at low tide and look at one of these old stumps, the cycle feels suddenly close. The wood is dark and soft, almost like old leather. The roots still hold their shape. You can see where bark once curled around the trunk. Above your head, gulls call over grey water. Below your feet, the floor of a forest that no living person ever saw. The same cycles that drowned this forest are still turning. Ice still melts. Seas still rise. Coastlines still shift, just more slowly than human attention usually notices. Somewhere out under the cold grey water, more forests lie buried in the mud, waiting for the next storm to uncover a single root, a single stump, a single small clue. How many such forests sleep beneath the North Sea? No one yet knows. The pages of pollen are long. The reading of them has only just begun. Picture, for a moment, the soft thunder of hooves on damp grass. A long, low plain stretches out beneath a grey northern sky. Tall reeds bend in the wind. Somewhere in the distance, a slow river winds through stands of birch and pine, and across this open country move animals so large they would seem almost impossible to us now. The herds of Doggerland are gone, but their bones still rest beneath the cold grey water, and the fishing nets of the North Sea bring them up, season after season, like quiet messengers from a vanished world. Mammoth tusks come up first, curved and heavy, stained the colour of old tea by long centuries in peat. Their owners were woolly mammoths, shaggy elephants of the cold north, with thick brown coats and small ears tucked close to the head. Some of the tusks pulled from the seabed are very old, from a time when the plain was deep in an ice age. Others are younger. The exact dates are still being argued over, but the bones themselves are real, sitting in museum drawers from the Netherlands to the east coast of England. Beside the mammoths walked the woolly rhinoceros, with its long front horn and a body built low and broad against the wind. Steppe bison moved in slow groups, their dark shoulders rising above the grass. Reindeer crossed in great seasonal lines, following the soft change of the weather. And the giant deer some people call the Irish elk, with antlers so wide a grown man could lie down between the tips, browsed the edges of the woodlands. As the climate warmed and the ice retreated, the cast of animals slowly changed. The mammoths and the woolly rhinos faded away. In their place came creatures suited to a milder, wetter land. Red deer drifted through the new forests. Roe deer slipped between the trees. Wild boar rooted in the soft earth along the rivers. And among them all moved the aurochs, the great wild cattle of old Europe, taller at the shoulder than most modern cows, with long forward curving horns and dark, almost black coats. Beavers built dams on the smaller streams, flooding shallow valleys into ponds and marshes. Otters slipped through the reeds. Wolves padded along the tree lines, watching the deer. Brown bears fished in the cold rivers and in the wetlands. Vast clouds of birds came and went with the seasons. Geese, ducks, swans, cranes, turning the sky into something that must have looked at times like moving weather. What we do not know is the exact balance of all this life. How thick were the herds? How many wolves the woodlands could hold? Whether certain corners of Doggerland were richer than others, with deep marshes full of fish and birds, while other corners were thin and stony. The seabed gives us pieces, but the pieces are scattered. A bone here, a tooth there, a clump of antler caught in a net 100 miles from anywhere. One question that researchers still sit with is how the changing animal world fits with the changing human world. The mammoth hunters of the older, colder plain are not the same people as the later hunters who tracked red deer through the birch forests. Their tools changed. Their camps changed. Their lives almost certainly changed in ways we can only partly guess at. One idea is that small bands followed the herds as they shifted, generation by generation, adapting quietly to whatever the warming land offered. Another idea is that the human population thinned and thickened in waves, leaving some parts of the plain empty for long stretches before being settled again. The sea, when it finally rose, did not only drown a landscape, it drowned a long-living network. Predators and prey, plants and pollinators, fish runs and bird migrations, all woven together over thousands of years. Some of those animals had places to retreat to. Red deer survived on what would become Britain, and across the European mainland, aurochs survived for thousands more years in the forests of Poland and beyond, until their final disappearance in the 17th century. Others had nowhere left to go, and their long story ended in the rising water. The herds that once crossed Doggerland are silent now. Their bones rest in the soft mud below the shipping lanes, sometimes 10 meters down, sometimes 30, sometimes more. And the question of what that world truly looked like, how loud, how full, how alive, is one we can only sketch in faint outlines. The fullness of it is still down there, in the dark, slowly turning into stone. To understand how Doggerland vanished, we have to think about ice. Not the thin film that forms on a winter puddle, not the floating crust on a pond. We have to think about ice in amounts so vast that the mind has trouble holding the picture. At the height of the last ice age, around 20,000 years ago, sheets of ice sat across the top of the world. They covered most of what is now Canada. They covered Scandinavia. They reached down across Scotland and into the northern edges of Germany. In places, this ice was more than 3 kilometers thick. That is nearly 2 miles of frozen weight, pressing down on the bare rock below. So much water was locked inside this ice that the oceans dropped. They dropped by roughly 120 meters compared to today. That is the height of a tall office tower. Every coastline you can picture on a modern map sat far out beyond where it sits now. The shallow shelves around continents lay exposed to the open air. The North Sea was not a sea at all. It was a cold, wide plain of grass and river valleys, walked by herds and by people. Then, very slowly, the world began to warm. The exact reasons are still studied and debated, but most researchers point to small shifts in the way the Earth tilts and orbits the Sun. These shifts changed how sunlight fell on the northern ice once. The melting began. It fed on itself. Bare ground absorbs more heat than white ice. Open water absorbs more heat than frozen sea. The thaw, once underway, was hard to stop. The numbers behind that thaw are quietly staggering. Over thousands of years, the great ice sheets gave back their water to the oceans. Sea levels rose by more than 100 meters in total. In some pulses, the rise may have averaged a meter or more each century. That is the height of a small child added to the tide line within a single human lifetime. For a flat land like Doggerland, where the slope of the ground was very gentle, even a small rise in the sea could swallow many kilometers of shoreline. One especially dramatic pulse is sometimes called Meltwater Pulse 1A. It happened around 14,000 years ago. During this event, sea levels may have risen by 16 to 20 meters in only a few centuries. Researchers still argue about the exact source. Some think most of the water came from the great ice sheet over North America. Others suspect that ice in Antarctica played a larger role than once believed. The question is not fully settled. Whatever the source, the consequences for low places were extreme. A shoreline could shift inland, not by meters, but by kilometers within a few generations. A family that hunted on a familiar marsh might watch that marsh become a bay. Their grandchildren might paddle canoes above the same ground. Their great-grandchildren might not even know it had ever been dry. Even the land itself was moving. The weight of the old ice had pushed Scandinavia and parts of Britain down into the Earth's mantle, the slow-flowing layer of hot rock beneath the crust. When the ice melted, those regions began to rise back up, like a sponge slowly recovering its shape. This rebound continues today, millimeters each year. But Doggerland sat in a strange place between the rising land and the sinking edges of the basin. As Scotland lifted, the southern North Sea quietly sagged. The plain was being drowned from above by rising water, and from below by sinking ground. The contrast between these two states of the planet is hard to picture. At the coldest extreme, a person could have walked from the hills of eastern England to the rivers of the Netherlands without ever seeing the sea. At the warmest extreme, ships now cross that same line in deep grey water, and divers find old peat layers far below the surface. Between those two worlds lay only a few thousand years of slow melting. What we still do not know is how the people on Doggerland understood any of it. Did they notice the change within a single lifetime, or did it stay just slow enough to feel normal? Did elders tell stories about beaches that used to be farther out? Did anyone count the steps between an old camp and the new water line? The melt was, by geological standards, extreme. By the standards of a person living through it, it may have felt like nothing more than weather and tides and the quiet year-by-year retreat of the only world they knew. Picture a coastline that no one ever named. A long, low shore of reeds and mudflats, soft and grey under a soft and grey sky. The water here does not crash. It only seeps a little further inland each season, a little higher up the old riverbank each spring. This was the daily texture of Doggerland in its final centuries. Not a flood, not a wave, just a patient, rising, slow as breath. The numbers are small, and that is what makes them strange. In the worst stretches of the long melt, the sea rose by perhaps 1 or 2 meters every 100 years. Over a single human life, that might mean a hand's width of water on a familiar shore. A child who learned to fish from a certain rock might, as an old man, find that rock half buried in salt grass. The shoreline never seemed to move, and yet it always did. Scientists who study these old shores look for the tiniest of clues. They sift through cores of mud pulled up from the seabed, long thin tubes of sediment that read like the pages of a slow book. Inside those cores, the layers stack one on top of the other. Black peat from an old marsh, pale silt from a quiet lagoon, a band of fine sand from a stormy year. Each layer is no thicker than a finger, but each one holds a season of the vanished world. Under a microscope, the smallest details begin to glow. Tiny shells, no bigger than a grain of rice, tell researchers whether the water was fresh, brackish, or fully salt. One species of foraminifera prefers a quiet estuary. Another prefers the open sea. As the layers shift from one species to the other, you can almost watch the salt water creeping inland, year by year, through the body of a single core. There are even smaller markers. Pollen grains drifting from old grasses and trees settle into the mud and stay there for 10,000 years. Each grain has its own shape, its own delicate sculpture, recognizable only at high magnification. Pine pollen looks like a tiny lobed bell. Oak pollen looks like a smooth seed with a faint scar. By counting the grains in each layer, scientists can sketch the slow retreat of the forests as the lowlands turn to marsh and the marsh turn to bay. Some cores contain small black flecks of charcoal. These hint at fires, perhaps natural, perhaps lit by people on a dry hilltop somewhere out across the plain. We cannot know which, but the flecks settle in the same layers as the pollen and the shells, and so they all speak together, in their quiet way, about a single season of a single year. The patterns are gentle, but they are not always smooth. In some cores, researchers find a thin band where the layers seem to skip, as if a stretch of time had been quietly erased. One idea is that a storm scoured the surface and carried it away. Another is that the land itself paused, that a marsh held its ground for a generation before yielding. The cause cannot quite decide, and neither can we. There is a particular beauty in the way salt arrives. It does not flood in all at once. It comes first as a faint chemical whisper in the groundwater under a freshwater pond. The reeds change slowly. The fish change. A snail that lived in the pond for 1,000 years suddenly cannot lay its eggs, and its shells become rare in the mud. A few centimeters above, in the next thin layer, a different snail appears, one that prefers brackish water. The handover is silent. No one living there would have noticed in a single lifetime. Trees on the edge of the shrinking land died standing up. Their roots, slowly drowned, lost their grip on the soil. Some of these old root systems still sit on the seafloor today, preserved by the cold and the dark. Divers describe them as ghostly stumps in the silt, the bark long gone, the wood soft as cheese. Yet the shape of each root, every fine branching tendril, remains. A tree that died 8,000 years ago can still show you exactly how it once reached into the ground. What we cannot see, and may never see, is the human side of this slowness. A grandmother pointing to a path that used to lead somewhere, a name for a hill that her grandchildren no longer needed. The quiet rituals of leaving a place that did not seem to be leaving you. Those details lie below the cause, beyond the microscope, in a silence that the rising water carried with it as it came. The story of how we learned about the great wave is itself a slow, careful tale. It is the story of patient people in quiet labs, looking at thin slices of mud and slowly realizing what those slices were telling them. The wave in question struck the northern edges of Doggerland thousands of years ago. We did not begin to understand it until very recently, and even now, much of what we say about it carries the soft edge of perhaps. The first clue came not from the sea, but from the steep coastline of Norway. In the late 1970s, geologists studying the seafloor west of that country noticed something strange in their maps. A great curved scar ran along the edge of the continental shelf, as if a vast piece of the ocean floor had simply slid away. They named the feature after a small island and stretch of coast called Storegga, which in Norwegian means the Great Edge. The maps showed that a huge mass of sediment had broken loose and tumbled into deeper water. Nobody yet knew when it had happened, or what it might have done. To find the date, researchers needed a different kind of evidence. They turned to the coastlines of Scotland, the Faroe Islands, and the low shores of eastern England. There, buried in old peat bogs and quiet estuaries, they began to find a strange grey layer. It sat between bands of dark soil, sometimes thick, sometimes thin, always out of place. The grey layer was sand, marine sand, full of broken shell fragments and tiny ocean creatures, lying far inland in places where the sea should never have reached. A Scottish geologist named David Smith spent years tracing this strange layer across hundreds of sites. Working with colleagues, he showed that the sand always appeared at the same depth, in the same period of time, in places hundreds of miles apart. It carried the unmistakable signature of a single, sudden event. Water had risen, rushed inland, dropped its load of sand and shell, and then drained away. The peat above and the peat below grew back slowly in the patient rhythm of ordinary centuries. But that thin grey line marked something that had happened in a single day. When the dates from these sand layers were compared with the dates from the underwater Storegga scar, the numbers lined up. Roughly 8,200 years ago, a piece of the sea floor the size of a small country broke free and slid into the deep. The displaced water would have surged outward in a vast wave by the time it reached the low shores of Doggerland. It may have been many meters high. This is where the story turns gentle and uncertain again. Researchers cannot say exactly how tall the wave was when it crossed the shrinking plain. They cannot say how far inland it traveled. They cannot say how many people, if any, stood in its path. The land it struck is now under cold grey water, and so the direct evidence is hard to reach. What we have are inferences drawn from the height of the sand layers on the surrounding coasts, and from careful computer models of how water moves. One theory holds that the wave was the moment Doggerland finally ended. By that time, the sea had already eaten away most of the old plain. Only a low island or two may have remained, surrounded by salt marsh and shallow lagoons. A single great surge could have washed across these last shreds of land and left them uninhabitable. Another theory is more cautious. It suggests that the wave was terrible, but not final, that the surviving land recovered, and that the true end came later, as the slow rising of the sea simply finished what the wave began. The instruments that revealed all this were not telescopes or grand machines. They were drills that pulled cores of mud from quiet bogs. They were sonar systems towed behind small ships. They were radiocarbon labs that measured the faint decay of ancient atoms in tiny pieces of wood and shell. The work was slow, undramatic, and spread across many decades and many countries. What we now know is that a great wave did sweep across the northern edge of this drowning world. What we do not know is whether anyone saw it coming, whether any story of it survived, or whether it truly closed the door on Doggerland, or merely pushed it nearly shut. The thin grey line in the peat tells us only that it happened. The rest is still waiting patiently beneath the cold water and the long centuries of silence. The strange thing about the Storegga slide is that it began nowhere near Doggerland at all. It began far to the north, off the coast of what is now Norway, on the edge of the continental shelf. There, in a stretch of seafloor called the Storegga Escarpment, a vast slab of underwater sediment let go and slid into deeper water. The slab was enormous. It carried roughly 3,000 cubic kilometers of mud, sand, and ancient seabed down into the abyss in a single slow-motion event. Most people, when they picture a tsunami, imagine an earthquake snapping a fault line under the sea. The Storegga slide was different. It was a landslide, but underwater and on a scale almost hard to picture. The slipping mass was longer than the entire coastline of Scotland. When it moved, it shoved a wall of water outward in every direction. That wall traveled across the North Sea and arrived at the shores of Doggerland and the surrounding lands roughly 8,200 years ago. What surprises many people is that we can still see the trace of that wave today. Along the eastern coast of Scotland, in quiet sea cliffs and old marsh layers, there is a thin band of pale sand sitting inside dark peat. The sand does not belong there. Peat forms slowly, in still wet places, from rotting plants. Sand belongs to the open sea, yet here, sandwiched between layers of bog, sits a stripe of marine sediment carried inland by a single great surge of water. Researchers have followed this same sand layer across Scotland, into Norway, into the Faroe Islands, and into parts of the eastern English coast. The counterintuitive part is how gentle the deposit looks. You might expect a tsunami to leave a wreckage of boulders and torn rock. Instead, it left a smooth, pale ribbon, sometimes only a few centimeters thick, tucked quietly inside older peat. Time has pressed it flat. A walker on a Scottish hillside could step over it without ever noticing the violence it records. For a long time, people assumed the Storegga wave was the moment Doggerland died. The story felt complete. A drowning land, a sudden wave, a final closing of the door. Newer work has complicated that picture. Sea level at the time of the slide was already very high. Much of Doggerland was already gone. What remained may have been a low scatter of islands, marshes, and shallow lagoons. The wave would have swept across these remnants with terrible force, but it likely did not, on its own, sink the country. The country was already mostly underwater. So the open question becomes more subtle. Did the Storegga wave end human life on the last islands of Doggerland in a single afternoon? Or did it strike a place that was already nearly empty and simply scour the last low ground clean? Some researchers suspect the wave was the final blow to small communities clinging to the highest remaining ridges. Others wonder if those communities had already left, moving inland to higher coasts long before the sediment slipped off the Norwegian shelf. The thin, pale sand cannot tell us which version is true. There is another strange detail worth sitting with. The Storegga slide may not have been a one-off event. Geologists studying the same stretch of seafloor have found evidence of earlier slides, much older, in the same area. The slope there seems prone to letting go every so often, perhaps when the sediment grows too heavy, or when methane trapped in the mud destabilizes the layers. Whether another slide could happen in the future is an open question. Most researchers think the conditions today are different and far more stable. Still, the seafloor north of Doggerland has a long memory of slipping. What makes the Storegga story so quietly haunting is the contrast between scale and silence. A wave that traveled across a sea, a landscape that may have lost its last shorelines in a single tide. And then, afterwards, nothing. No written record, no marker stones, only a thin, pale band of sand, hidden inside peat, waiting to be noticed thousands of years later by someone with a careful eye and a small spade. Whatever happened that day, the water did not retreat for long. The slow tide of melting ice kept rising. The marshes that survived the wave were soon claimed by ordinary sea, and the strange truth at the heart of this chapter is that the loudest moment in Doggerland's final centuries left almost no trace at all, except a quiet stripe of sand in a Scottish bog, and a long silence beneath the cold grey water of the North Sea. The sea floor under the North Sea is not a blank page. It is a kind of slow library, written in mud and sand and old plant matter, and the words on its pages were placed there by many different hands. Rivers wrote some of them. Glaciers wrote others. The sea itself wrote the last few chapters. To read the story of Doggerland, you have to understand how all these forces still speak to each other across thousands of years. Think first of the rivers. Long before the North Sea filled in, great rivers crossed this lowland. The Rhine, the Thames, the Meuse, and others wandered across the plain, joining together, splitting apart, leaving deep channels in the soft ground. Those channels are still there, hidden under the seabed. Sonar surveys have traced them like old roads on a forgotten map. The water moves differently above them, even now. Sediments collect inside their curves. The shape of the lost rivers shapes the shape of the modern sea. The ice played its part too. When the great northern ice sheets pressed down on the land, they squeezed the crust beneath them. The ground bowed under the weight, like a cushion under a heavy stone. When the ice melted, the land slowly began to lift again. This slow rising still continues. Parts of Scotland and Scandinavia are creeping upward by a few millimeters each year. Parts of southern England and the Low Countries are slowly sinking in response as the crust settles back into balance. Doggerland sat near the hinge of this slow movement. Its fate was tied to ice it never touched, melting hundreds of miles to the north. The sun, of course, set everything in motion. Small shifts in the angle of Earth's tilt and the shape of its orbit changed how much sunlight fell on the northern ice. Over thousands of years, these gentle shifts pushed the climate to warming. The ice began to thin. Meltwater poured into the sea levels climbed. The same patient sunlight that grew the forests of Doggerland also, in the end, drowned them. One system fed another, slowly and without hurry. The ocean itself carries memory in its currents. As the fresh water from melting ice poured into the North Atlantic, it likely changed the way warm and cold water mixed. Some researchers think these changes affected the great conveyor of ocean circulation, which moves heat from the tropics toward the poles. Others think the effect was smaller or shorter than once believed. The question remains open. What seems clear is that the climate of Northern Europe, even today, depends on currents that were once disturbed by the same melt that swallowed Doggerland. Even the air remembers. Pollen drifts on the wind and falls into still water, where it sinks into mud and stays. Core samples drilled from the seabed contain layers of pollen that record what grew above. Pine, birch, hazel, oak, grasses and reeds. The mud holds the breath of vanished forests. Above those layers sit darker bands of peat, then marine sediment, then sand. The whole sequence is a quiet record of land becoming marsh, marsh becoming lagoon, lagoon becoming sea. Animals leave their own connections. Mammoth bones from Doggerland share chemistry with mammoth bones found on land in the Netherlands and England. Their teeth carry traces of the plants they ate, plants that grew on a single shared plain. Fish in the modern North Sea swim above the bones of creatures that once walked on dry ground. The food web of today drifts above the food web of long ago. They are not the same web, but they share the same floor. Even human history connects across the water. Stone tools found on the English coast, match tools found on the Danish coast. The styles are too similar to be a coincidence. People moved across Doggerland, traded across it, perhaps spoke across it. When the land vanished, those connections did not vanish all at once. They thinned. They stretched into boat journeys. They reshaped themselves around the new sea. So the seafloor is not really silent. It hums quietly with the work of rivers that no longer flow, ice that no longer presses, forests that no longer stand, and people who no longer walk. Each system left a mark. Each mark still shapes the present in small ways. The path of a current, the height of a coast, the chemistry of a sediment, the route of a migrating fish. The mystery of Doggerland is not the mystery of a single lost place. It is the mystery of how every part of Earth holds onto every other part, long after the surface has changed beyond recognition. The cold water above keeps the secret gently and goes on remembering. For most of human history, the floor of the North Sea was simply a hidden place. Sailors knew its depths only through long ropes weighted with lead, lowered hand over hand into the dark water. They could measure how deep the bottom was at one small point, then move the ship a little and measure again. It was patient work and slow, and it gave them only the faintest sketch of what lay below. The sea kept its shape mostly to itself. That began to change in the 20th century, when ships started using sound to listen for the seafloor. A sharp pulse would leave the hull, travel down through the cold water, bounce off the mud below, and return. By timing that echo the crew could tell how far the bottom was beneath them. Early versions drew a single line of depth along the path of the ship. Later versions sent out fans of sound, sweeping wide swaths of the seabed in one pass. Slowly, decade by decade, the hidden floor of the North Sea began to take shape on paper. What appeared on those new maps surprised many of the people who studied them. The seabed was not the smooth, featureless plain some had imagined. It was carved and shaped like the surface of a country viewed from very high above. There were long, winding channels that looked very much like old river valleys. There were low ridges that resembled the banks of streams. There were broad, shallow basins that could have held lakes. The cold grey water had been hiding a landscape with a memory of its own. A great deal of this mapping was not done for the sake of curiosity. Oil and gas companies wanted to know the seabed in detail, so they could plan pipelines and drilling platforms. Offshore wind farms needed careful surveys before their giant towers could be sunk into the mud. Cable companies wanted safe paths for the long lines that carry information beneath the ocean. The data they collected, gathered for very practical reasons, became a quiet gift to the scientists studying the lost plain. Researchers began to gather these surveys together and stitch them into larger pictures. From thousands of overlapping scans, they built three-dimensional models of the seabed across wide areas. In those models, the ghost of an ancient countryside began to appear. One long curving channel, traced across hundreds of kilometers, seems to follow the path of a river that drained much of northern Europe in deep time. Other channels branch off from it, like the smaller streams of a great watershed. The shapes feel familiar because they are the shapes of land. Still, even the best sonar maps leave most of the story untold. They can show the rough form of a valley, but not the trees that once grew along its banks. They can hint at a lake bed, but not the reeds at its edge or the fish in its shallows. They can outline a low rise that might have been a hill where people camped, but they cannot show the camp itself. The maps are like the bones of a body without its skin. Much imagination is still required, and much caution. There is also the problem of time. The channels seen on the seafloor were not all carved in the same age. Some are very old, from periods when the area was dry during earlier ice ages. Others formed more recently, in the warmer thousands of years before the final flooding. Sorting one from the other is slow, careful work. A river valley, visible today on a sonar image, may have held water long before any human walked beside it, or it may have been a familiar landmark to the last hunters of the plain. The maps alone cannot always say which. New tools keep arriving. Autonomous vehicles, small and quiet, can drift along close to the seabed and gather much sharper images than ships above. Sediment cores, drill down into the mud, bring up layered records of pollen and grains and tiny shells. When these cores are matched to the sonar maps, the flat shapes begin to gain depth and meaning. A channel becomes a river that once carried snowmelt. A basin becomes a lake that once held summer light, yet the picture is still being drawn. Vast areas of the North Sea floor remain only roughly known. Other areas, mapped in detail for industry, have not yet been studied carefully by archaeologists. The shape of the lost valleys is emerging slowly, one survey at a time, like a photograph developing in a dark room. For now, much of that drowned country still waits beneath the cold water, holding its quiet shape, half remembered, half revealed. There is a kind of light that lives inside old peat, not light you can see with your eyes, but light that was once captured by leaves long ago and held in the soft tissues of plants. When sunlight fell on the great plain of Doggerland, it warmed the broad leaves of alder and willow, the needles of pine, the slender blades of marsh grass. Some of that sunlight became wood, some became seed, some became pollen, drifting on the warm spring air in clouds so fine the human eye would barely notice. That pollen settled into ponds and bogs and slow river bends, layer by layer. The soft mud closed over it. The pollen grains, tough and waxy, did not rot away. They stayed where they fell. And when the sea rose and covered the plain, the cold salt water sealed them in even more tightly, like pages pressed inside a heavy book. Today, scientists pull cores of that buried mud up through the seafloor. The cores look like long, dark sticks of layered cake, striped in browns and greys and soft greens. Under a microscope, each layer gives up its hidden cargo. A single thimble of ancient peat can hold tens of thousands of pollen grains. Each grain has its own shape. Birch pollen looks like a tiny triangle with 3 small pores. Oak pollen is round and rough. Pine pollen carries 2 little air sacs, like a swimmer with floats. By counting these shapes, researchers can read what kinds of trees stood there, and roughly when. The picture that comes out of the mud is gentle and slow. After the great ice sheets pulled back, the land warmed. First came the grasses and low shrubs, the dwarf birch hugging the cold ground. Then, as centuries passed, taller birches arrived, and with them the hazel, sending its yellow catkins into the wind. Pine forests spread across the dry uplands. In the wetter hollows, alder and willow leaned over slow streams. Oak and elm came later, casting deeper shade. Each of these layers holds a memory of light. The pale gold light of birch woods in early summer, the warm green of hazel thickets, the dim, dappled light beneath an oak. We cannot stand inside those forests anymore. The forests themselves have been gone for thousands of years. But the pollen tells us they were there, and how the colors of the land changed as the climate softened. The peat itself is another kind of record. In the cold storage of the seabed, ancient peat sometimes survives almost intact. Trawlers occasionally bring up dark, fibrous lumps that still smell faintly of forest floor. Inside those lumps are twigs, leaves, beetle wings, even small seeds. One theory among researchers is that some of these peat beds formed in low coastal marshes where the land was already losing its battle with the rising sea. Another view holds that many of the deepest peats formed earlier, in true inland bogs, far from any shore. Both ideas may be partly right, and the exact pattern across the old plain remains an open question. There is a quieter sort of light, hidden in the peat too. Carbon, locked away in those plant tissues, carries the faint signature of the sun that grew them. When scientists measure the radioactive carbon in a sample, they are, in a way, reading the age of that captured sunlight. A piece of waterlogged wood pulled from the North Sea floor might whisper that its tree was alive 9,000 years ago, or 11,000, or more. The numbers help researchers stitch together a rough timeline of how the forests came and went. Yet the timeline is full of gaps. Cores are expensive to take. The seabed is vast. For every square mile that has been sampled, hundreds remain unread. Whole valleys of pollen sit untouched in the dark. We do not know if certain rare trees grew on Doggerland or not. We do not know exactly when the last great forests gave way to salt marsh, or how patchy that change was from place to place. Some scientists suspect there were small refuges of woodland that held on longer than the rest. Others wonder if the final retreat was more even, more uniform. The evidence is thin, and honest researchers admit it. Still, the mud remembers more than the open water above it ever will. Somewhere beneath the grey waves tonight, A sliver of ancient pollen is waiting in its dark lair. It carries the colors of a vanished spring, the soft gold of hazel and the green of new oak leaves, light from a sun that set on a country no living person has ever seen. If you could stand on the old plain of Doggerland on a quiet morning, the soundscape would not be silent. Reeds would rustle in a soft wind, water would lap at the edge of a slow river. Somewhere far off, a flock of geese would call to each other across a marsh. A red deer might splash through shallow water at the forest edge. And perhaps you would hear something else. The low murmur of human voices, the thud of an axe against wood, the crack of a hearth fire. The question is how often and how loud those human sounds would have been. How many people actually lived on this drowned land, we do not know. That is one of the quieter mysteries of Doggerland. We can imagine the geese and the deer. We have bones for those. But the people themselves left only scattered traces, a few tools, a few worked pieces of bone, a handful of footprints preserved in old mud. From these small clues, we try to picture a whole population. It is like hearing one or two notes and trying to guess the size of the choir. Some researchers think Doggerland may have held many thousands of people at its peak. The land was rich. Rivers ran slow and wide. Marshes teemed with birds and fish. Forests offered nuts, berries, and game. For hunter-gatherer groups, this was prime country. A place that could feed many small bands moving through it season by season. By this view, the Lost Plain may have been one of the most populated parts of northwest Europe at the time, a green heartland, now hidden under cold grey water. Other researchers urge caution. The fact that the land could feed many people does not mean it did. Hunter-gatherer populations tend to stay thin and spread out. Even rich land may have held only small bands, gathering at certain seasons and scattering again. By this view, the human sound of Doggerland was mostly soft. A few voices around a fire, a child laughing somewhere across a meadow, then long stretches of wind and water with no one near at all. The question stays open. Part of the trouble is that the seabed hides almost everything. On dry land, archaeologists can walk a field and find old flint flakes scattered in the soil. They can map where people lived and worked under the North Sea. That kind of patient ground search is nearly impossible. Divers can reach only small areas. Sonar shows shapes, but not stone tools. The evidence comes mostly by accident, from fishing nets and dredges. So our picture of the people is built from the few finds that have happened to come up. It is almost certainly incomplete. There is also the matter of time. Doggerland did not exist as one fixed country. It changed across thousands of years early on. When the ice still gripped much of the north, the climate was harsh, and the human presence was probably thin. Later, as the climate warmed, forests spread and the land grew kinder. Population may have risen. Later still, as the sea began to rise and the land began to shrink, people may have been pushed onto narrower and narrower ground. For a brief window, the remaining land may have been more crowded than ever before, as groups retreated from the flooding edges, or people may have simply moved away early, leaving the shrinking plain to a few stubborn bands. Both pictures are possible. The data cannot yet tell us which is closer to the truth. There are hints, though. A small island in the modern North Sea, near the coast of the Netherlands, has yielded a surprising number of Mesolithic objects washed up on its beaches. Worked flints, bone points, pieces of human skull. The objects come from the seabed nearby, stirred up by storms and currents. Each find is a faint signal from the lost population, a whisper across thousands of years. Each one says, We were here. None of them say how many. So when you listen in your mind to the sound of old Doggerland, you have to choose your own volume. You can imagine a quiet land with scattered fires glowing in the dusk, voices few and far between. Or you can imagine a busier place with paths worn between camps, smoke rising from many hearths, children calling out across the reeds. Both versions sit in the realm of the possible. The seabed has not yet told us which is right. Maybe in time, more finds will lift the curtain a little. For now, we listen and we guess, and we let the question stay unanswered as we drift. There is a quiet mathematics inside this mystery, though it is not the kind written on a chalkboard. It is the math of generations, of words passed from mouth to mouth, of how long a single story can survive when no one writes it down. The people who lived on the sunken plain left no books. They left no carved tablets, no painted symbols we can read. Yet they almost certainly spoke. They almost certainly told one another stories by firelight. And so we are left with a gentle question, one that has no clean answer. How much of what they said could possibly have reached us, and how much has been lost to the cold grey water for good? Linguists have tried to measure the lifespan of words. Some words seem to last a very long time. Simple words for mother, for water, for fire, for 2 and 3 can be traced across thousands of years and across many related languages. Other words drift away within a few centuries, replaced by new sounds, new shapes, new fashions of speaking. The rough math suggests that a spoken language reshapes itself almost completely every few thousand years. Doggerland sank beneath the waves around 8,000 years ago. That is many lifetimes of drift, many quiet replacements of one word by another in mouths that no longer exist. This is where the numbers turn delicate. If a language changes by even a small fraction each generation, those small fractions stack up. 25 years to a generation, 320 generations between us and the last people who walked that plain. Even gentle change, compounded that many times, becomes a wall we cannot easily climb back over. Some researchers think a few echoes might still survive in the older layers of European languages, hidden inside, place names or river names that were borrowed and reborrowed before anyone thought to write them down. Other researchers doubt this. They believe the drift is simply too great, the gaps too wide, and that any true word from Doggerland is gone beyond recovery. Stories may travel further than words. A tale can be retold in a new language and keep most of its shape. There are flood stories in many cultures around the world, and some scholars have wondered whether a few of them carry faint memories of real coastlines that vanished. One careful idea is that the slow drowning of low plains, repeated across many parts of the world at the end of the last ice age, may have left a soft imprint on the imagination of the people who survived. A competing idea is simpler. Floods happen everywhere, rivers rise, coasts shift. People everywhere invent flood stories because water is powerful and memory is short. Both ideas can be argued, and neither can be proven from where we sit now. The mathematics of oral memory is its own quiet study. Experiments suggest that a story, retold faithfully and ritually, can survive for many centuries. Some indigenous traditions in Australia appear to describe coastlines that were last above water more than 7,000 years ago, and a few scholars have pointed to this as evidence that very old memories can, in the right conditions, endure. Whether such endurance was possible among the small bands who lived on Doggerland is unknown. Their numbers were small, their world ended. The people who survived the flooding scattered and mixed with others, and the chain of telling may simply have broken. There is a kind of elegance in counting what we cannot recover. If we imagine a single song sung by a single family on the edge of a slowly drowning marsh, and we ask how many times that song would need to be passed forward to reach us, the answer is something like 300 careful retellings, each one a small act of trust between a parent and a child, each one a tiny chance for the song to be forgotten, or changed, or set aside in favor of something new. 300 chances to fail. The wonder is not that such a song is lost. The wonder is that anything at all from that time has reached us. The seafloor holds its bones and its tools, and the language of stone is patient. The language of speech is not. Somewhere in the silt, beneath fishing lanes and shipping channels, the last words ever spoken on that plain still hang in the air of a vanished evening. And then they are gone. What those words were, what gods or rivers or beloved names they carried, we cannot know. The mathematics is gentle and a little sad. It tells us only how easily a whole world of voices can slip beneath the surface, leaving the water above it perfectly quiet. Doggerland is not alone. All around the world, beneath shallow seas and quiet bays, other lost lands lie waiting. They tell a wider story. They remind us that the line between land and water has never been fixed. It has moved, again and again, across the slow turning of the ages. Think for a moment about the Persian Gulf. Today it is a warm, shallow sea, lined with sand and salt, but during the last ice age, much of it was dry. Rivers we still know by name, the Tigris and the Euphrates, flowed across that exposed floor. They joined other streams from Arabia and Iran. Together they ran out across a long, low plain before meeting the distant sea. Some researchers wonder if early people lived along those vanished riverbanks. Some imagine villages, fishing camps, marshes thick with reeds. The evidence is scarce, because the water came back just as it did over Doggerland. What remains lies hidden under soft mud. Far to the east, the picture is even larger. The Sunda Shelf off the coast of Southeast Asia once joined the islands of Indonesia, Malaysia, and Borneo into a single great landmass. Some researchers call this lost world Sundayland. Its rivers were vast, its forests stretched for thousands of miles. Then the ice melted, the seas rose, and the lowlands drowned. What survived became the islands we know today. The hills became coastlines, the valleys became straits, and much of the old plain now sleeps beneath warm tropical water, full of coral and slow-moving fish. There is also Beringia, the broad land bridge that once linked Siberia to Alaska. For a long time it was dry. Grasslands grew there. Mammoths walked across it. Some researchers believe people crossed it slowly, generation after generation, into the empty continents beyond. Then the sea returned and cut the bridge in two. Today, only the cold waters of the Bering Strait remain, with two small islands marking where the old plain used to rise, closer to Europe. Off the coast of India, there are drowned shells where ancient rivers once carved valleys into stone. Off the coast of Australia, the old shoreline lies far out from the present one, and some Aboriginal traditions speak of times when the sea came in and swallowed the country. Whether those stories carry the memory of real flooding from thousands of years ago is still debated. Some researchers see them as genuine ancestral records. Others are more cautious and say the matches may be coincidence. The question stays open. What strikes you when you place all these drowned lands side by side is how thin the balance really is. The world feels solid. The coastlines on our maps look firm, but they are only the shape of this moment. A small change in temperature, a slow shift in the great sheets of ice, and the line moves. A few degrees warmer, and water that was locked up as ice begins to flow. Beaches retreat, estuaries widen, lowlands become bays. Doggerland is one chapter in a much longer book. Each drowned land formed under its own rivers, its own animals, its own quiet patterns of life. Each was lost in its own way, some slowly, some in sudden surges, some perhaps in a mix of both. And in every case, what is left is the same kind of silence. A seafloor, a scatter of bones, a few stone tools brought up in a net or pulled from the dark by a diver. It is humbling to think how narrow the conditions are that allow any of this to happen at all. Earth sits at just the right distance from the sun for water to be liquid most places, most of the time. The tilt of the planet gives us seasons. The slow wobble of its axis nudges the climate over tens of thousands of years. A small shift in any of these and the ice grows, or the ice melts, and the shorelines walk inland or out to sea. Doggerland was not an accident. It was the natural shape of the world during a colder time. Its drowning was not an accident either. It was the natural shape of the world warming again. Other lands follow the same arc. Others may yet follow it in ages to come. For now, the cold grey water of the North Sea rolls above the old plain. Warm Gulf water laps over the old rivers of Arabia. Tropical seas drift across the lost forests of Sundayland. Each one a quiet reminder that the map we know is only the map for now. So much remains hidden beneath the North Sea. After more than a century of dredging, mapping, and careful study, the drowned country still keeps most of its secrets. The water above it is shallow by ocean standards, rarely more than 100 meters deep. And yet that thin grey ceiling has been enough to hide entire chapters of the human past. The questions that remain are not small ones. They are some of the largest open questions in Northern European archaeology. We still do not know, for instance, how many people lived on this land at its peak. Estimates range widely, from a few thousand scattered hunters to tens of thousands moving through the river valleys in loose, seasonal bands. Each estimate rests on a different set of guesses about how rich the land was, how much food it could produce, and how mobile its people were. Both views may be partly right, both may be partly wrong. The truth lies somewhere in the cold sediment, waiting. We also do not know where the main settlements were. On dry land, archaeologists look for hearths, post holes, scatters of flint, the soft footprints of repeated living. Under the sea, those traces are harder to find. A camp that lasted a single summer might leave almost nothing behind. A village that stood for generations might now be buried under meters of marine clay. Some researchers suspect that the largest settlements would have clustered along the great river mouths and lake shores, the same places that drew people everywhere else in prehistory. Others wonder if the people of this land moved too often to leave permanent villages at all. The shape of their daily lives remains an open question. The path of the final flooding is another puzzle. We know the sea rose. We know the Storegga slide sent a wave across what was left of the northern coast. But the exact order of events is still being pieced together. Did people retreat slowly, generation by generation, watching the water creep inland, a few steps each year? Did certain low islands vanish suddenly during a single stormy winter, while others held on for centuries? Were there moments of relative calm, when the sea seemed to pause and the survivors thought the worst was over? The seafloor holds the answer, layer by layer, but reading those layers is slow work. There are also deeper questions about the land itself. We have only mapped a small fraction of the old surface in any real detail. Most of what we know comes from a scatter of survey lines, oil and gas data, and the occasional research expedition. Between those lines lie thousands of square kilometers of unexplored terrain, lost river bends, forgotten hills, quiet valleys where, perhaps, a hearth still rests under the silt. Each new survey adds a few more pixels to the picture, and each new pixel raises new questions. The biology of the lost land is also incomplete. We have bones from mammoths, aurochs, red deer, brown bears, beavers, and many smaller creatures. We have pollen from oak, hazel, alder, and pine, but we do not have a full census of the living world that filled those forests and marshes. Some species may have lived only here, in this particular cold temperate corner of Europe, and vanished with the land. Others may have crossed back into Britain or the continent before the water closed in. Which animals made which choice, and why, is still being worked out. Even the climate is uncertain in its fine details. The broad story of warming after the last ice age is well understood. The smaller swings, the cool centuries, the warm decades, the wet summers and dry ones, are harder to recover. Each of these would have shaped where people could live and how the coastline moved. The sediment cores tell part of this story, but only part. And then there is the question of memory. Did anything of this lost world survive in the stories told by later peoples around the North Sea rim? Tales of floods, of drowned villages, of lands beneath the waves appear in many northern traditions. Some researchers wonder whether faint echoes of the real flooding might linger in their stories. Others doubt that oral memory could carry across so many thousands of years. There is no way at present to know. What is striking is that none of these gaps feel like dead ends. Each one is a doorway, new sonar systems, new coring techniques, new ways of recovering ancient DNA from seabed mud. All of them are slowly opening that door a little wider. The mystery is not closing. It is unfolding, season by season, survey by survey, into something larger and more patient than any single answer. Tonight, we have wandered about a country that vanished. We have walked across its plains in our minds, listened to its rivers, watched its forests sink under cold grey water. Now let us wander forward instead of back. Let us ask what becomes of this sunken plain in the long centuries and the long ages still ahead. In the near future, measured in decades, the seabed where Doggerland sleeps will keep changing in small ways. Sand will shift, sediment will settle, new wind farms will rise in the shallow water, their pale towers standing where ancient hunters once tracked deer. Each time engineers drive a foundation into the seabed, they touch a layer of buried peat or clay that remembers the old forest floor. Some of those touches will bring up bone, or flint, or worked wood. The map of the drowned country will fill in, slowly, one accidental discovery at a time. In a few centuries, the sea above Doggerland may rise again. Many researchers think a warming climate will lift global sea levels by a meter, perhaps more. Others suggest the rise could be larger or smaller, depending on how the great ice sheets behave. The question is still open, but if the water does climb, the shallow shelf will simply grow deeper. The old plain will fall further from the light. The bones in the seabed will rest beneath an even thicker blanket of cold water. In 10,000 years, the picture grows stranger. Some scientists wonder whether the world is heading toward another ice age on the slow, natural rhythm that has shaped the last million years. Others think human warming may delay or cancel that rhythm. If a new ice age does come, the sea would fall again, ice would lock up the world's water, the shoreline would retreat, and Doggerland could rise once more into the air. A future people, if they exist, might walk across mudflats and find mammoth tusks and stone tools resting where they were dropped. Or they might find nothing at all, scoured away by the long centuries of waves. Both outcomes are possible. Neither is certain. In a million years, the very shape of the basin will have shifted. The British Isles sit on a slowly moving piece of crust. The North Sea floor itself flexes and settles. Rivers cut new paths. Sediment from the Rhine and the Thames and the rivers of northern Europe will keep pouring into the basin, layer upon quiet layer. Whatever is left of the old human campsites will be pressed deeper into rock. Stone tools may become small dark shapes inside pale sandstone. The forests that once grew on the plain will be thin black seams of compressed peat, the kind future geologists might call a coal in 10 million years. The continents themselves will have drifted into new positions. Africa is creeping north toward Europe. The Mediterranean is slowly closing. Some researchers think that in tens of millions of years, the collision will raise new mountains across southern Europe and reshape the whole region. The North Sea may shrink, or deepen, or be lifted up entirely. The drowned country could end up high and dry, a layer of fossil peat on the side of a future hill, or it could be subducted, pulled down into the hot rock below, and erased. In 100 million years, the question of Doggerland becomes almost meaningless. The Atlantic will be wider. The shape of the coast will be unrecognizable. Any trace of the Mesolithic hunters, if it survives at all, will be a faint chemical signature in a stripe of ancient rock. A trained eye, if such eyes still exist, might read that stripe and say, "Here, once, there were trees, and in 1 billion years, the sun itself will be brighter and hotter. The oceans may begin to thin. Earth will still be here, but it will be a different Earth, warmer, drier, stranger. The cold grey sea above the sunken plain will be long gone. So will the plain, so will the question of what its people knew, what they spoke, what stories they told around their fires. This is the gentle truth at the end of every Earth mystery. The thing we wonder about is moving, even now, towards something we cannot picture. The drowned country will not stay drowned forever. It will not stay anything forever. It will become rock, then mountain, then dust, then sea again. In slow turns, we will not live to see. For tonight, it is enough to know that the change is still happening, quietly, far beneath the waves, while we rest. There is a question worth sitting with, here near the end of our long quiet wandering. Why do we keep going back to the cold grey water? Why do scientists spend whole careers studying a place no one alive has ever seen above the waves? The North Sea is not warm. It is not easy to work in. The seafloor gives up its secret slowly, one bone, one pollen grain, one buried valley at a time, and still the searching continues. Part of the answer is simple curiosity. We are a species that wants to know. We have always wanted to know. Long before there were maps, our ancestors climbed hills to see what lay beyond. They followed rivers to find their sources. They crossed water to reach the next shore. The same quiet pull that once moved hunters across the drowned plain now moves researchers across the same waters in steel ships, looking down with sound. But there is something else too, something deeper. When we look at Doggerland, we are looking at ourselves in a long mirror. The people who lived there were us. Their bones are like our bones. Their hands made tools the way our hands still shape things today. They watched their children play. They told stories at night. They wondered about the world the same way we wonder about them now. To search the cold water is to reach back toward kin we never met. Pull the view back further, and the story grows even quieter. The atoms in those ancient bones were not made on Earth. The calcium that built a Mesolithic child's small wrist was forged inside ancient stars that lived and died long before our planet existed. When those stars collapsed, they scattered their heavy elements across the dark. Those elements drifted for ages. Some of them gathered into the cloud that became our sun, our world, our oceans, our forests, our bodies. The hunter who lost an antler harpoon in a Doggerland river was made of stardust. So is the trawler captain whose net pulled that harpoon up thousands of years later. So are you, lying still and listening. The water above the drowned plain is part of the same long story. Every drop has cycled through clouds and rivers and the breath of ancient animals. The rain that falls on the North Sea today may once have fallen on a Doggerland forest. The salt in the waves may once have washed the shore of a vanished island. Nothing leaves the system. Nothing is truly lost. It only changes shape and waits. This is perhaps why the searching feels so meaningful, even when the finds are small. A single fragment of worked flint, dredged up by accident, is a thread. Pull on it gently, and it connects to a hand. The hand connects to a body. The body connects to a family, to a language, to a way of seeing the world. The family connects to the plain to the rivers to the melting ice, the ice to the climate to the slow turning of the planet around its star. Everything is connected. Every thread leads outward into a story so large it cannot be held in one mind. And yet here we are, holding pieces of it anyway, quietly, patiently, one sonar pass at a time, one core sample at a time, one pollen grain at a time. The work is slow because the world is old, and old things ask to be approached gently. The mystery of Doggerland will not be solved in a single discovery. There will be no final map, no triumphant moment when every question is answered. The plain is too large, the water is too deep, too much time has passed. What we will have, instead, is a slow brightening of understanding. Each generation of researchers will see a little more than the last. Each will pass their work on to those who come after. The way the Mesolithic people passed their tools and their stories to their own children. Somewhere out there, in the cold grey water, the old forest floor is still waiting. The river valleys are still there, buried in sediment, holding their shape. The bones of the mammoths are still resting in the dark. The harpoons are still where their owners last set them down. None of it has gone anywhere. It is simply quiet now, beneath the waves, beneath the ships, beneath the long, slow weather of the world. We may learn more in our lifetime. We may not. The story is older than we are, and patient. For tonight it is enough to know the plain is there, and to wonder about it, and to let the wandering carry us gently towards sleep. So here we are, at the soft edge of the night, drifting somewhere above an old forest floor that no living eye has seen. The water above it is dark and slow. The waves on the surface rise and fall in their long, patient rhythm, the way they have for thousands of years. Below them, the sand holds its quiet secrets. A piece of antler, a blackened root, a flint chip the size of a fingernail, none of them in any hurry to be found. Think of the North Sea tonight as a vast grey blanket pulled gently over a sleeping country. The country is still there, It did not vanish. It only lowered itself beneath the water, layer by layer, century by century, until the trees became peat, and the peat became seabed, and the seabed became the dim floor over which the fishing boats now pass. The world above is loud with engines and lights. The world below is soft and dark and almost perfectly still. You can picture the moon above the sea now if you like, a pale disk, half hidden by thin cloud, laying a silver path across the water. The path stretches all the way from the coast of Britain to the coast of the Netherlands, right across the place where Doggerland used to be. If you could walk that silver path, you would be walking over hills you cannot see, over riverbeds that no longer flow, over the quiet outlines of a country that has earned its long rest. We talked tonight about so many open questions. How many people once lived on that plain? What songs they sang around their small fires, whether any memory of the flooding survived in the oldest stories of Europe, or whether it slipped away with the last generation who saw the shoreline move. We talked about the Storegga slide and the great wave that may have raced across the lowlands. We talked about mammoths and aurochs, about pollen grains held in peat, about sonar beams sweeping the dark floor like slow searchlights. None of those questions were fully answered. That is the gift of a place like Doggerland. It gives us something to wonder about without ever demanding that we solve it. The sea is patient. The seabed is patient. They will hold their evidence for as long as they need to, and they will release it slowly in fragments to the patient hands that go looking. There is something kind about a planet that keeps a few of its chapters hidden. It means there is always more to learn. It means the world is older and deeper than any single life can hold. It means that tonight, while you rest, somewhere out there, a wave is rolling over a sunken hillside, and a small fish is moving through the shadow of a drowned valley, and the earth is going about its long, quiet work without needing anyone to watch. Let your breathing slow now. Let your shoulders soften into whatever is holding you. Imagine the planet turning gently in the dark, the oceans rocking in their basins, the great slow currents threading through the deep. Imagine the moon above the North Sea, and the silver path on the water, and the old forest floor far below, sleeping the way you are about to sleep. Nothing down there needs anything from you. The mammoth bones are at rest. The antler harpoon is at rest. The peat that was once a meadow is at rest. The hunters who walked those plains have been at rest for thousands of years, and the land they walked has joined them, folded gently into the sea. The world simply continues. Tides rise and fall. Rivers find new mouths. Coasts shift by the width of a hand each century. And we, small and warm and breathing, get to wonder about all of it for a little while. Tomorrow there will be more questions, more cold water to think about, more quiet places on this old planet that still keep their secrets. For tonight, though, the work is done. The mystery is still a mystery, and that is exactly as it should be. Some questions are not meant to be closed. They are meant to be carried softly into sleep, like a small lantern set down beside the bed. Rest now above the old forest floor. Rest above the silver path on the dark sea. Rest with the gentle knowledge that the earth is vast and patient, and that it is holding you, just as it holds the drowned plain, with the same quiet care. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.